Welcome to solverfy.
So for part A of our question, the ray enters normal to the first surface, so there is no deviation there. And the angle of incident is 45 degrees at the second surface. Where there is air outside the surface, we're going to have the following relationship. So for part A, go ahead and make use of Snell's law, of course. So N1 times the sine of theta 1 is equal to the index of refraction N2 times the sine of theta 2. Okay, so replace this with the values that we know, which is theta 1 and theta 2. Oh, I wrote theta 2 here. This should be theta 1. Change that. So we know theta 1 and theta 2. So we have N1 times the sine of 45 degrees is equal to 1, that's the index of refraction N2, times the sine of theta 2. So for total internal reflection to occur, we need the sine of theta 2 to be greater than 1. So we need sine theta 2 to be greater than 1. In order for total internal reflection to occur. Therefore, we need N1, index of refraction 1, to be greater than or equal to 1 divided by the sine of 45 degrees to make that true. Which 1 over the sine of 45 degrees is equal to 1.4. So N1 must be greater than or equal to 1.4. We can box that in as a solution for part A. Okay, so now we'll go ahead and do part B. For part B, when there is water outside the surface, we're going to have the following. Again, using Snell's law, where the first index of refraction we're told is 1.58 times the sine of 45 degrees which is equal to, index of refraction of water is 1.33 times the sine of theta 2, and we don't know theta 2. Okay, so therefore, solving for sine of theta 2, we find that this is equal to 1.58 divided by, that's not a very good looking 8, we'll redraw that, 1.58 divided by 1.33 multiplied by 1 over the sine of 45 degrees. So carrying out this expression, we find that this is equal to 0.84. And 0.84 is clearly less than 1. And since it's less than 1, the prism is not totally reflected. So we'll go ahead and write that out because that's what we were asked to find. So prism not totally reflected. And the reason being because 0.84 is clearly less than 1. So we can box all of that in as our solution for part B. Okay, and then lastly, we'll move on for part C. So for total reflection, when there is water outside the surface, we're going to have the following. Again, using Snell's law, we have N1 times the sine of 45 degrees is equal to 1.33, the index of refraction of water, times the sine of theta 2. So for total internal reflection to occur, we need the sine of theta 2 to be greater than or equal to 1. So we need sine theta 2 to be greater than or equal to 1 in order for total internal reflection to occur. Therefore, we need N1 to be greater than or equal to 1.33 divided by the sine of 45 degrees. Which is equal to 1.9. So we need N1 to be greater than or equal to 1.9. And we can box that in as our solution to part C.